Welcome back. In this video, we'll take a look at my buck converter project as an electrical engineering student. We'll take a look at the theory of a buck converter, and then we'll turn to the practical side of this project. So let's start. So this is what our buck converter looks like. Right here, we have our input voltage of 9 volt DC. Here we have our two resistors with their heat sinks. This one here is a passive resistor. This one is an active resistor, and the buck converter converts these 9 volts into 2 volts. Right here we have our inductor. These are our capacitors, and in the center we find this chip where our two synchronous MOSFETs are placed. Through these pins we will read the ADCs and feed the PWMs. So let's take a look at our schematic. This is the schematic of the buck converter that we have just seen in real life. Don't get scared. The only things we need are here are our 9 volts to ground. This here are our synchronous MOSFETs. You can think of them as switches. So switch number 1, switch number 2. This one is our inductor. These are our capacitors. And here we can find our load resistors. Load resistor number 1 and load resistor number 2. Okay, let's break this down. So, a DC-DC buck converter in theory looks like this. We have two switches, this one and this one, an inductor, a capacitor, a passive load, and an active load. That's why I drew it like that. We have our output voltage of 2 volts and our input voltage of 9 volts. And through switching the switch number 1, we chop our input voltage. This is our conversion rate. We can calculate it by dividing the output voltage with the input voltage. So let's take a look at the time curves and the switching states. Let's first take a look at the state when switch number 1 is closed and switch number 2 is open. This is what we see here. Then our inductor voltage is U in minus U out. Our inductor current forms a line with a positive slope, and so does our current through switch number 1. Now let's take a look when we open switch number 1 and close switch number 2. That's this off state here. Then our inductor voltage will become negative, namely minus U out. Our inductor current will form a line with a negative slope, and so does our current through switch number 2. Perfect. The other day I was in the lab and I connected the buck converter to the microcontroller and to a 9 volt DC power supply. Then I programmed the microcontroller using X2C and Code Composer Studio, and I downloaded the program onto the microcontroller. Then I took an oscilloscope and tried to measure the output voltage and the inductor current. Now let's see how they look like in a chart. This red line is the inductor current and this blue line is the output voltage. The interesting part here is the transient process. Here's where I turned on the input voltage, and after some time you have a stable 2 volts DC at the output. This is a buck converter. Now the next steps will be implementing different control algorithms.